long after the last human memory disappears, after the oceans have boiled away from Earth, after the sun itself has collapsed into a dead ember drifting through darkness, the universe will continue. Not dramatically, not with fire, but with silence. Somewhere in that distant future, a single particle of light may still be moving through empty space. It will cross distances so large that entire galaxies would once have fit between its starting point and its destination. But by then, galaxies themselves will already be gone, their stars extinguished, their structures unravelled, their black holes evaporated into thin radiation spread across impossible emptiness. And still, the photon will continue. This is one of the first uncomfortable truths hidden inside modern cosmology. The universe does not end when life ends. It does not end when stars die. It may not even end when matter itself disappears. Human beings naturally imagine endings as events, a final explosion, a collapse, a wall at the edge of time. We instinctively search for conclusions that resemble stories, because human lives are built from beginnings and endings measured in decades. But the cosmos does not appear to share that instinct. According to our best physical models, the true ending of the universe may not be an event at all. It may be a process so slow that entire civilizations would vanish before noticing the first measurable change. Right now, the night sky still gives the illusion of abundance. Thousands of stars, rivers of galaxies, explosions of colour captured by telescopes orbiting above Earth's atmosphere. Even the darkness between stars appears alive with possibility. But this picture is temporary. The universe is not static. It is burning through its structure. Every star you see tonight is consuming finite reserves of order. Inside stellar cores, hydrogen atoms are being crushed together under immense pressure, creating heavier elements and releasing light into the darkness. This process feels eternal to human minds because a single star can survive for billions of years. But billions of years are small on cosmic scales, almost incomprehensibly small. If the entire lifespan of the universe were compressed into a single Earth year, human civilization would occupy less than the final second before midnight on December 31st. Agriculture, language, empire, religion, industry, digital technology, every war ever fought, every human face that has ever existed, all of it would appear and disappear almost instantly. And yet even that vast timeline represents only the early youth of the cosmos, because the frightening reality is that the universe may spend most of its existence dead. Not destroyed. Dead. There is a difference. Destruction implies violence. It implies action. But the future described by physics is colder than violence. It is quieter, a gradual draining away of usable energy until the cosmos becomes incapable of supporting motion. Life, memory, or structure, the stars will not all vanish together. They will disappear one at a time, slowly, almost politely, for trillions upon trillions of years. The universe will dim by degrees too small for any living creature to emotionally understand. Entire galaxies will become graveyards of burned-out stellar corpses drifting farther apart as cosmic expansion stretches space itself. Eventually, even the night sky will disappear. Future observers, if any observers still exist, may look upward and see nothing at all. No galaxies, no evidence that other islands of matter ever existed. Expansion will carry distant structures so far away that their light can no longer reach one another. The universe will become isolated in fragments, each alone, each trapped inside its own shrinking horizon of visibility. And this is where human intuition begins to fail, because emptiness on cosmic scales is not like emptiness on Earth. A deserted building still contains echoes, air, dust, gravity, the memory of life. But cosmic emptiness is something far more absolute. The average density of matter in intergalactic space is already close to perfect vacuum. In many regions, A single atom may drift alone for enormous distances before encountering another particle. The future universe expands this emptiness until isolation itself becomes the dominant feature of reality. Not darkness, not cold, isolation. The atoms inside your body were forged inside ancient stars that died before Earth existed. The calcium in your bones, the oxygen in your blood, the iron moving through your cells all emerged from stellar furnaces billions of years ago. Human beings are physically constructed from temporary moments of cosmic warmth. And warmth is rare, more fragile than most people realize. The deeper scientists look into the far future, the more unsettling the picture becomes. Not because the universe appears violent, but because it appears indifferent to complexity itself. Every structure eventually dissolves. Every energy source runs down. Every organized system drifts toward equilibrium. Even black holes, once believed eternal, now appear temporary, which means the cosmos may be moving toward a state beyond ruin, a condition where nothing meaningful can ever happen again. No stars, no planets, no biology, no memory. Only thin radiation spreading through distances so immense that words like distance and time begin losing psychological meaning. And yet, strangely, the universe will still exist. That is perhaps the most difficult part to accept. Reality may continue indefinitely after the final chapter of everything recognizable, a future where the cosmos survives its own usefulness, where existence itself becomes an endless monument to everything that is gone. For most of human history, the universe felt stable. The ground beneath our feet appeared permanent. The stars returned each night with reassuring precision. Seasons repeated. Generations rose and vanished beneath skies that seemed untouched by time. Even civilizations that understood death rarely imagined that the cosmos itself could die. Ancient astronomers looked upward and saw eternity. Not because they were naive, but because the illusion is deeply convincing. The stars do not appear temporary to human eyes. They do not flicker with weakness or reveal signs of exhaustion. A child can look at the night sky and see almost the same constellations that guided sailors thousands of years ago. Orion still stands over winter horizons. The Pleiades still gather like scattered frost. The band of the Milky Way still stretches faintly across dark skies far from cities. Human intuition quietly absorbs a dangerous assumption from this consistency, that the universe is built to last. Even today, despite modern science, most people emotionally imagine reality as something fundamentally ongoing. Galaxies continue spinning, new stars continue forming, planets continue orbiting. There is always another sunrise somewhere, another civilization perhaps emerging around another distant sun. The cosmos feels active, alive, endlessly replenishing itself, and on the scale of human lives, this assumption appears reasonable. The sun has burned for roughly 4.6 billion years already, long before Earth formed. Nuclear fusion had already ignited in its core. Dinosaurs lived and disappeared beneath its light. Ice ages came and went. Entire branches of evolution rose from oceans, walked onto land, vanished into extinction, and were replaced by others. Throughout all of it, the sun remained reliable, steady. Its stability shapes human psychology more deeply than we notice. Every biological rhythm inside the human body evolved beneath predictable cycles of warmth and light. Circadian clocks, sleep patterns, migration instincts, seasonal agriculture, even the emotional symbolism humans attach to dawn and darkness, all of it emerged because our star behaves consistently enough to make long-term life possible. Stars feel eternal because evolution required them to feel eternal, but this comfort comes from scale mismatch. Human beings evolved to understand survival across days, years, and generations, perhaps centuries at most. The brain was never designed to emotionally process billions or trillions of years. Once time expands beyond biological intuition, permanence becomes difficult to judge correctly. A mountain appears permanent to a mayfly. A star appears permanent to a species, but permanence in the universe is often only slowness. What humans call eternal is usually just something dying at a pace we cannot naturally perceive. The sun itself is slowly changing right now. Every second, deep inside its core, approximately 600 million tons of hydrogen fuse into helium. A fraction of that mass becomes energy according to Einstein's relation between matter and radiation. That energy struggles outward through dense solar layers for thousands or even millions of years before finally escaping into space as sunlight. Some of the photons warming your skin today may have begun their journey outward long before human civilization existed. And even this enormous furnace is temporary. In roughly 5 billion years, the sun will exhaust most of the hydrogen in its core. Gravity and fusion will fall out of balance. The core will contract. Outer layers will swell outward into a red giant large enough to consume Mercury and Venus, possibly Earth itself. Long before that final expansion, our planet's oceans will already have evaporated beneath increasing solar heat. Continents will bake under temperatures hostile to complex life. Earth will become sterile while the sun is still technically alive. This realization quietly altered humanity's understanding of reality. For the first time, science revealed that even stars are mortal. And once that idea enters the mind, it begins spreading outward. If stars die, galaxies change. If galaxies change, perhaps the universe changes too. The comfortable picture begins to crack. But emotionally, most people still imagine cosmic death as distant enough to remain abstract. 5 billion years feels safely remote. The brain treats it almost like infinity. It does not provoke fear because it cannot be visualized through lived experience. Yet the universe measures time differently. Compared to the true future ahead, the entire lifespan of the sun is only an early chapter. Even the oldest stars currently visible are still part of a relatively youthful cosmos. The universe today remains crowded with active galaxies, where enormous clouds of hydrogen continue collapsing into newborn stars. Supernovae still scatter heavy elements across interstellar space. Black holes still feed. Planetary systems still assemble from disks of gas and dust. Creation is still happening. That fact creates psychological comfort. It allows humans to unconsciously imagine a future where existence continues renewing itself forever. But modern cosmology has uncovered a disturbing asymmetry hidden beneath this activity. The universe creates structure only temporarily. Stars form because usable energy still exists in concentrated forms. Gravity pulls matter together faster than entropy can spread it apart. Galaxies still possess immense reservoirs of hydrogen left over from the early universe. But those reservoirs are finite. The cosmos is not replenishing itself. It is spending itself. Every star born today slightly reduces the universe's future ability to produce stars later. Every explosion, every burst of radiation, every orbiting system slowly converts concentrated energy into thinner, colder distributions that cannot easily be used again. The process resembles a fire-consuming fuel, except the fire lasts for trillions of years, and the fuel is the structure of the cosmos itself. This changes the emotional meaning of the night sky. The stars stop looking eternal and begin resembling candles inside an enormous darkening room. Some burn brightly and die quickly. Massive blue stars may survive only a few million years before exploding violently. Smaller red dwarfs burn with extraordinary efficiency and may endure for trillions of years, but none last forever. The universe allows temporary islands of order, temporary pockets where chemistry, biology, consciousness, and memory become possible. Human civilization emerged during one of these brief windows, not near the beginning of cosmic history, and possibly nowhere near the end, but during a rare era when the universe was still warm enough, dense enough, and structured enough to permit complexity. This realization introduces a subtle but profound discomfort. The conditions necessary for life may not be normal. They may be cosmologically brief, a temporary phase between two immense oceans of darkness. And the deeper science looks into the future, and the more fragile this phase begins to appear. Because the real problem is not simply that stars die, it is that eventually the universe may stop making new ones at all. Right now, somewhere inside the Milky Way, a cloud of gas is collapsing. Gravity is pulling hydrogen inward through darkness so cold and diffuse that no human eye could ever witness it directly. Over immense spans of time, the cloud tightens, density increases, temperature rises, atoms begin colliding faster and faster until, eventually, pressure inside the forming core becomes extreme enough to ignite nuclear fusion. A new star is born. This process has happened for most of cosmic history. Entire galaxies glitter because gravity continuously gathers matter into luminous furnaces that push back against the surrounding dark. Human beings instinctively assume this cycle is permanent. Dead stars replaced by new stars. Galaxies renewing themselves endlessly like forests regrowing after fire. But this is where the universe begins revealing a more unsettling reality. Star formation is slowing down. Not dramatically enough for human civilization to notice. Not on timescales measured in history books or civilizations. But on cosmic scales, the decline is unmistakable. The universe is already quieter than it used to be. Billions of years ago, galaxies were violent places. Young stars formed at extraordinary rates inside dense rivers of gas left over from the early universe. Collisions between galaxies triggered massive waves of stellar birth. Quasars blazed around, supermassive black holes bright enough to outshine entire galaxies. Radiation flooded space in every direction. The cosmos was crowded with activity, energetic, restless. In some regions, stars formed hundreds of times faster than they do inside the modern Milky Way. But that era is ending. Astronomers now estimate that the universe produces only a small fraction of the stars it once did during its peak epoch of star formation, roughly 10 billion years ago. The great reservoirs of cold hydrogen gas inside galaxies are gradually being depleted. Some is locked permanently inside stars. Some is blown away by supernova explosions. Some falls into black holes. Some becomes too diffuse to collapse efficiently ever again. The universe still creates stars, but less eagerly than before. And this introduces one of the first truly uncomfortable implications about cosmic mortality. The universe had a youth, which means it may also have an old age. Human beings rarely think about the cosmos biologically, but the comparison becomes difficult to avoid. Young organisms grow rapidly. They consume energy aggressively. Activity peaks early, then, slowly, processes begin declining. Systems lose efficiency. Resources diminish. Structures become harder to maintain. Something disturbingly similar appears to be happening to reality itself. Not because the universe is alive, but because thermodynamics imposes irreversible direction onto physical systems. The cosmos is evolving from concentrated energy toward dispersion, from activity toward equilibrium, from brightness toward darkness, and the distances involved make this psychologically difficult to absorb. The Milky Way alone contains hundreds of billions of stars. Beyond it lie perhaps trillions of other galaxies scattered across the observable universe. Human intuition sees such numbers and assumes abundance on an effectively infinite scale. But abundance is not the same as renewal. Imagine standing beside an enormous forest containing trillions of trees. At first glance, it appears inexhaustible. Then imagine learning that no new trees will ever grow again. The forest may remain beautiful for a very long time. Wind may still move through branches. Leaves may still fall. But the future's fundamentally changed. The system is no longer alive in the same way. It has quietly transitioned from growth into consumption. Modern cosmology suggests the universe may already exist inside this transition. And what makes the realization more disturbing is how early humanity arrived. Civilization emerged while the cosmos still glows with active stellar creation. We were born during one of the brightest eras reality will ever experience. The night sky visible above ancient deserts, medieval oceans, modern cities, and future colonies may represent an unusually luminous chapter in cosmic history, most of the universe's future may not resemble this at all, because eventually star formation will end almost completely. Not tomorrow, not for trillions of years, but inevitability does not become less real simply because it unfolds slowly. The smallest stars, red dwarfs, will survive longest. These dim stellar embers burn fuel with extraordinary efficiency. Some may continue glowing for over 10 trillion years. Around them, lonely planets could remain warm long after brighter stars have died. If life persists anywhere deep into the future, it may exist beneath the faint red skies of these ancient stars. But even red dwarfs eventually exhaust themselves. One by one, the lights go out. The future universe becomes populated not by suns, but by remnants, white dwarfs, neutron stars, black holes, cold planetary corpses drifting through expanding darkness. And this is where human imagination begins failing again. Because human beings instinctively picture the future as populated. Cities replacing cities, generations replacing generations, new forms of life inheriting old worlds. The mind expects continuity because biological existence depends on continuity. But the universe offers no guarantee that complexity continues indefinitely. In fact, the deeper physics becomes understood, the more temporary complexity appears. Even galaxies themselves are fragile structures suspended against enormous odds. Stars orbit galactic centers because gravity temporarily overpowers cosmic expansion on local scales. But the larger fabric of space continues stretching outward everywhere simultaneously, and that expansion is accelerating. This discovery, confirmed through observations of distant supernovae in the late 20th century, radically altered humanity's understanding of the future. Astronomers once debated whether gravity might eventually halt expansion and collapse the universe inward again. Instead, evidence suggested the opposite. The expansion of the universe is speeding up. Galaxies are moving away from one another faster over time, not because they travel through space like ordinary objects, but because space itself expands between them. This distinction matters. The universe is not empty space containing galaxies. The universe includes space itself, and space is growing, which means the future cosmos is not merely aging, it is becoming more isolated. Over billions and trillions of years, distant galaxies will recede beyond observable reach. Their light will stretch into wavelengths so long and faint that future observers inside the Milky Way's merged galactic remnant may eventually see only darkness beyond their local group of stars. The wider universe will become invisible. Imagine being born in that distant era. No evidence of the Big Bang. No visible galaxies beyond your own. No cosmic background radiation detectable. An observer might reasonably conclude the entire universe consists only of a single isolated galaxy surrounded by eternal darkness. The true scale of reality would already have disappeared beyond the horizon of observation. Even knowledge itself becomes temporary. This is where the emotional character of cosmology changes. The future no longer feels merely distant. It begins feeling lonely, because the universe is not simply running out of stars. It is slowly dismantling every bridge between structures. Galaxies drift apart. Matter decays toward lower energy states. Heat spreads thinner. Light weakens. Distances widen. And beneath all of it lies a deeper realization still waiting to emerge. The stars are not the foundation of reality. They are only brief interruptions in an overwhelmingly dark universe. Darkness is the natural condition of the universe. Human beings rarely feel this emotionally because life evolved beside a star. Every creature that has ever walked Earth inherited instincts shaped by warmth, daylight, and repeating cycles of illumination. Even night on our planet is softened by atmospheric glow, moonlight, distant cities, and the constant presence of the sun just beneath the horizon. True cosmic darkness is something else entirely. It is not merely the absence of visible light, it is distance made physical. A region so empty and cold that a beam of light can travel for millions of years without encountering anything substantial at all. And the deeper astronomers looked into space, the more they discover that this darkness dominates reality. Galaxies appear enormous in photographs because human images compress unimaginable scales into manageable frames. The spiral arms of the Milky Way seem dense with stars. Nebulae appear crowded with glowing gas. Clusters of galaxies resemble islands pressed closely together, but these pictures quietly deceive the brain. The cosmos is mostly emptiness. If the sun were reduced to the size of a grain of sand, Earth would orbit several feet away. Neptune would drift hundreds of feet farther outward. The nearest star would still be thousands of miles distant. Almost the entire model would consist of vacant space, and even space between stars is comparatively crowded compared to the void between galaxies. Human language struggles here because words like empty and far lose precision at these scales. The observable universe contains perhaps 2 trillion galaxies spread across a diameter of roughly 93 billion light-years. The numbers sound overwhelming at first, until one realizes how much nothingness exists between each structure. Reality is sparse, violently sparse. Galaxies themselves drift through enormous cosmic voids, where almost no matter exists at all. Some of these voids span hundreds of millions of light-years. A civilization crossing one would travel longer than multicellular life has existed on Earth without encountering another galaxy. The universe does not resemble a crowded ocean of stars. It resembles isolated embers suspended inside nearly infinite blackness. This realization becomes more unsettling once modern cosmology reveals how fragile those embers actually are. Because stars are not stable objects in the ordinary sense. They are temporary negotiations between gravity and pressure. Gravity tries constantly to crush matter inward. Fusion pushes outward against collapse. A star survives only while these forces remain balanced. The moment the balance fails, the star changes forever. Massive stars collapse catastrophically. Outer layers explode across interstellar space in supernova eruptions brighter than entire galaxies. Smaller stars swell into red giants before shedding their atmospheres into expanding shells of gas. Eventually, mostly behind stellar remnants, dense corpses, white dwarfs, neutron stars, black holes. The visible universe humans emotionally associate with reality is built from temporary burning phases that occupy only a fraction of cosmic time. This is where the normal mental picture begins truly breaking apart, because human intuition assumes stable environments produce stable universes. But stars are not stable. Galaxies are not stable. Even atoms may not be stable forever. The cosmos only appears permanent because humans exist during an unusually active chapter of its history. Astronomers sometimes call the current era the stelliferous era, the age of stars. It began hundreds of millions of years after the Big Bang. Once the first stars ignited from primordial hydrogen and helium, it will continue for trillions of years more while red dwarfs slowly consume their fuel. To human minds, trillions of years already feel indistinguishable from eternity, but cosmologically, the stelliferous era may represent only a brief luminous interval between vastly longer ages of darkness. This is the first crack that changes the emotional meaning of existence itself. Human civilization was not born into a permanent universe. It was born into a temporary metabolic phase, a moment when the cosmos still possessed enough concentrated energy to support light, chemistry, and memory matters more than most people realize. Every thought inside the human brain depends on ordered energy flows. Neurons exchange signals through electrochemical gradients, maintained by metabolism powered ultimately by sunlight. Civilization itself is an elaborate thermodynamic structure. Cities, computers, agriculture, language, archives, satellites all exist because concentrated energy remains available. The future universe gradually removes this possibility, not through violence, through exhaustion. The process is governed by one of the most important principles in physics, entropy. Entropy is often described as disorder, but the deeper reality is more unsettling. Entropy measures the spreading out of energy. Systems naturally evolve from concentrated, usable states toward diffuse, unusable ones. Heat flows outward. Differences equalize. Structure becomes harder to maintain. A lit candle inside a dark room illustrates the principle perfectly. The flame consumes wax while releasing heat and light into the surrounding air. Eventually the wax runs out. The room absorbs the energy. The candle cannot spontaneously rebuild itself because the energy has already dispersed. Now imagine the entire universe behaving this way. Stars are candles, galaxies are temporary clusters of candles, and the cosmos itself may be the rooms slowly absorbing their fading heat. The terrifying implication is not merely that individual objects die, it is that the universe may possess a preferred direction toward lifelessness. Every star that shines slightly increases total entropy. Every supernova spreads concentrated matter farther outward. Every black hole consumes organized structure while radiating almost imperceptibly back into space. Time itself appears tied to this irreversible drift from order toward equilibrium, which means the future may not simply contain death. It may increasingly prohibit complexity altogether. The laws of physics still permit temporary local structures. Planets form, life emerges, intelligence evolves. But these are fluctuations occurring inside a larger thermodynamic descent, like brief whirlpools inside a river flowing towards stillness. This changes the emotional position of humanity within the cosmos. Civilization stops feeling central. Even biological life stops feeling central. Instead, life appears as a temporary side effect of energy gradients that existed during one narrow phase of cosmic evolution, a rare interval when the universe was sufficiently ordered to permit thinking matter. And disturbingly, the universe may not care whether such thinking matter continues. There is no evidence that complexity is cosmically protected. No known law guarantees intelligence survives. The equations governing stellar evolutions, gravity, thermodynamics, and expansion proceed without reference to consciousness at all. Stars burn, space expands, entropy rises, reality continues. Human meaning exists only locally. Temporarily, against this backdrop, the future becomes difficult to emotionally process. Because what awaits is not simply extinction, but gradual irrelevance. The cosmos may continue for spans of time so enormous that the entire age of stars eventually resembles only a brief flash near the beginning, an early bright moment before the long dark. And beyond that darkness lies something even stranger, because when the stars finally disappear, the universe does not end. It merely enters another phase. Imagine standing on a planet orbiting the final star. Not the last star in a galaxy, not the last star visible from Earth. The final star anywhere. Around it, the universe has already grown ancient beyond ordinary comprehension. Every large, bright star disappeared trillions upon trillions of years earlier. Spiral galaxies unraveled into diffuse stellar clouds. Violent eras of collisions and supernovae faded into memory long before memory itself became rare. Only dim red dwarfs remain. Small stars, quiet stars. Stars so efficient that they burn their fuel with extraordinary patience, conserving warmth across spans of time almost impossible for biological minds to emotionally absorb. One of these final stars glows faintly in endless darkness. Its light would feel weak compared to the sun. Deep red, distant, barely sufficient to illuminate the surface of nearby worlds. Yet by this era, even such weak warmth would represent something precious beyond measure, because almost the entire universe would already be dead. This is where cosmic scale becomes psychologically dangerous. Human beings are accustomed to measuring time against civilization. Empires rise and collapse across centuries. Religions survive millennia. Species endure millions of years. Even geological transformations on Earth unfold across spans large enough to humble ordinary intuition. But cosmic futures dwarf all of them so completely that human history begins resembling atomic motion inside a storm. Consider this carefully. If every second since the birth of human civilization were counted one by one without pause, the total would still represent only a tiny fragment of cosmic history already elapsed. And yet, the future predicted by astrophysics extends incomparably farther still. 1,000,000,000,000 years? 10 trillion? A quadrillion? Numbers stop functioning emotionally long before this point. The brain loses all instinctive reference, which creates a profound problem when attempting to understand the fate of the universe. Human imagination quietly compresses enormous durations into abstraction. We hear the numbers, but psychologically experience them as interchangeable forms of very long time. Physics does not make this simplification. The difference between 1,000,000,000 years and 1,000,000,000,000 years is roughly equivalent to the difference between a single second and over 30,000 years. And even 1,000,000,000,000 years may represent only the beginning of the universe's decline. By then, nearly all ordinary stellar formation will already have ceased. Galaxies will contain mostly stellar remnants orbiting through darkness. Encounters between stars become rarer as expansion increases cosmic isolation. Matter itself gradually redistributes into colder and less useful arrangements. Yet paradoxically, the universe will still remain active in certain ways. The future cosmos does not die all at once. It decays unevenly. Small red dwarf stars continue glowing while larger structures vanish around them. Gravitational interactions slowly rearrange galaxies over unimaginable spans. Some dead stars collide. Occasionally, two white dwarfs merge violently enough to trigger new bursts of fusion. Tiny flickers against overwhelming dark, like sparks surviving after a fire is almost completely burned out. But eventually even the red dwarfs fail. This transition marks one of the most haunting thresholds in cosmic history, because red dwarfs are not merely the longest-lived stars, they are the final natural engines of warmth the universe will possess. A red dwarf may survive for 10 trillion years because it consumes hydrogen with extraordinary restraint. Unlike larger stars, which burn furiously and die young, red dwarfs spend almost their entire existence slowly converting fuel into dim light. Some have not yet died because the universe itself is not old enough. Every red dwarf that has ever formed still exists. But one day, even these ancient survivors will exhaust their fuel. And when they do, the stelliferous era, the age of stars, finally ends. Not with an explosion. With embers fading, the universe enters what some physicists call the degenerate era, a strangely clinical term for a profoundly lonely reality. By this stage, ordinary stars are gone. What remains are stellar corpses, white dwarfs, neutron stars, brown dwarfs, and black holes drifting through enormous darkness. Planets continue orbiting dead remnants long after all sunlight disappears. Frozen worlds move invisibly through space, colder than anything naturally occurring in the present universe. If civilizations survived this long and enormous uncertainty, they would inhabit a cosmos fundamentally unlike the one humanity evolved within. No bright galaxies filling the sky, no ongoing stellar birth, no luminous nebulae, only remnants, ancient objects preserving faint traces of a vanished energetic universe. And even these remnants are temporary. White dwarfs gradually cool into black dwarfs' cold stellar ashes, no longer emitting meaningful heat or light. The process takes so long that no black dwarfs yet exist anywhere in the current universe. Reality itself is still too young, but eventually, countless invisible stellar corpses will drift through darkness like abandoned ruins of a forgotten cosmological age. The emotional implications deepen further when one considers what expansion is doing simultaneously. The observable universe shrinks over time, not physically, but observationally, because galaxies beyond our local gravitational group recede faster and faster due to accelerating expansion. Their light stretches towards wavelengths so large that it becomes effectively undetectable. Future observers trillions of years from now may see no evidence whatsoever that other galaxies ever existed. Imagine the loneliness of such a civilization. Born inside darkness, surrounded only by dead stars and black holes. No visible origin story in the sky. No cosmic microwave background radiation. No expanding galaxies revealing the Big Bang. the larger universe would already have disappeared beyond observational reach. Cosmology itself might become impossible. The true scale of reality erased by time. This is one of the strangest consequences of cosmic expansion. The universe was actually easier to understand earlier in its history. Humanity emerged during a rare era when evidence of cosmic origins remained visible. Future intelligences may inherit a far more deceptive cosmos, a smaller-looking universe, an emptier one, a universe falsely suggesting eternal stillness because almost all dynamic structures already vanished. And yet the actual future extends vastly farther still. Even after the final stars die, time continues. This realization becomes emotionally destabilizing because human intuition expects important processes to conclude once visible activity ends. But physics allows reality to persist across intervals so enormous that the age of stars eventually becomes only a tiny bright chapter near the beginning of everything. The future after starlight may last incomprehensibly longer than the luminous universe itself. Imagine compressing the entire history of stars, every galaxy, every civilization, every planetary ocean, every biological organism that ever lived beneath sunlight into a single day. The remaining future afterward would still stretch longer than millions of years. The darkness dominates the timeline, and inside that darkness, gravity continues working slowly, patiently. Black holes drift through expanding emptiness, occasionally swallowing dead stars or merging with one another. Stellar remnants gravitationally scatter each other across galaxies already dissolving into isolation. Matter decays toward thinner distributions. The universe becomes quieter with each passing epoch, not because motion stops, but because meaningful structure becomes rarer. The cosmos begins resembling an enormous abandoned machine still running after its purpose has disappeared, and somewhere deep inside that future, beyond the death of every star, beyond the freezing of every planet, another realization begins emerging from the mathematics. Even black holes may not survive forever. For much of the 20th century, black holes appeared to represent the closest thing the universe possessed to permanence. They were portrayed as cosmic endpoints, final objects, regions where gravity became so overwhelming that escape itself ceased to exist. Once matter crossed the event horizon, it vanished permanently from the observable universe. Light could not return. Information seemed trapped forever inside a collapsing well of curved space-time. In an aging cosmos filled with dying stars, black holes looked eternal. And emotionally, this idea carried strange weight. Even if galaxies vanished and civilizations disappeared, perhaps something would remain, some final structures enduring against the erosion of time. Immense dark anchors surviving after everything luminous had already gone cold. But modern physics introduced a quieter and far more disturbing possibility. Black holes may also die. Not quickly, not violently, but inevitably. To understand why, it becomes necessary to descend deeper into the strange relationship between gravity, quantum mechanics, and emptiness itself. Human intuition imagines vacuum as nothingness, an absence, a perfect void, but quantum physics reveal that empty space is not truly empty at all. Even the vacuum possesses fluctuating energy fields. Tiny particle pairs briefly emerge and annihilate continuously across space itself. Normally, these fluctuations vanish almost instantly, leaving no lasting effect on large-scale reality. Near a black hole, however, the situation changes. In the 1970s, physicist Stephen Hawking demonstrated that quantum effects near an event horizon allow black holes to emit tiny amounts of thermal radiation. This process is now known as Hawking radiation. The implication was extraordinary. Black holes are not entirely black. They slowly lose energy. And because energy and mass are equivalent, losing energy means losing mass, which means black holes gradually evaporate. At first glance, the process sounds almost insignificant. Large black holes emit extraordinarily little radiation, A stellar mass black hole absorbs far more energy from the cosmic microwave background today than it emits. Even supermassive black holes containing billions of solar masses radiate at temperatures far colder than interstellar space. Right now, the universe is still too warm for black hole evaporation to dominate, but the future changes this balance. As the cosmos expands, background radiation continues cooling, galaxies drift farther apart, stars disappear, energy spreads thinner through space. Eventually the universe becomes cold enough that black holes begin losing more energy than they absorb, and once that threshold is crossed, evaporation becomes irreversible. This realization shattered one of the last intuitive notions of permanence in physics. Even black holes are temporary structures. The timescales involved are almost impossible to emotionally process. A black hole with the mass of the Sun would require roughly 1067 years to fully evaporate. That number is so immense that ordinary comparison begins collapsing. It exceeds the current age of the universe by a factor of trillions upon trillions upon trillions upon trillions upon trillions. And yet supermassive black holes survive vastly longer still. The enormous black hole at the centre of the Milky Way Sagittarius asterisk may persist for roughly 1087 years before finally evaporating. Larger ones endure even beyond this. These durations push reality beyond meaningful biological imagination. Human civilization has existed for only a few thousand years. Complex multicellular life on Earth spans perhaps 600 million. Even stars themselves survive mere billions or trillions compared to the future lifespan of black holes. By the time the final black holes begin dying, every familiar structure in the universe will already have vanished unimaginably long ago. No planets, no stars, no galaxies visible across the void, only isolated black holes drifting through nearly absolute darkness. And eventually, even they begin disappearing one particle at a time. The emotional character of this future is difficult to describe because it violates ordinary expectations about endings. Humans associate death with acceleration. Hearts stop suddenly. Buildings collapse rapidly. Civilizations may fall across generations. But black hole evaporation unfolds with almost unbearable slowness. For most of its lifespan, a black hole changes imperceptibly. Then, near the end, the process accelerates dramatically. As black holes lose mass, they emit radiation faster. Smaller black holes evaporate more intensely than larger ones. A once enormous gravitational abyss eventually shrinks into something microscopic and unstable. Finally, after spans of time so vast that language itself may no longer hold meaning anywhere in the universe, the black hole releases its remaining energy in a brief burst of radiation. Then it is gone. No monument remains, no scar in space, only thinner radiation spreading into larger darkness. This is one of the deepest scientific reversals in modern cosmology. The objects once believed eternal are revealed to be temporary, and with them disappears another illusion humans quietly carry about reality, the belief that sufficiently massive structures can resist time forever. Nothing yet discovered in physics appears exempt from change. Stars burn out, galaxies disperse, black holes evaporate, even space-time itself may not remain stable indefinitely. The universe increasingly resembles a system dismantling every form of permanence it creates. But perhaps the strangest implication emerges from thermodynamics. Black holes were once thought to violate entropy because they appear to erase information. Matter falls inward. Organized structures disappear behind the event horizon. Yet Hawking's work connected black holes directly to entropy itself. In fact, black holes possess enormous entropy greater than almost any other known object. They are not exceptions to thermodynamic decline, they are expressions of it. The future universe therefore does not escape entropy through black holes, it deepens into entropy through them. Over unimaginable durations, black holes absorb the remnants of stars, gas, planets, and radiation while slowly converting concentrated mass into diffuse thermal energy spread across expanding space. The cosmos becomes smoother, colder, more uniform. And this trend matters because structure depends on imbalance. Life exists because Earth receives concentrated solar energy against the colder backdrop of space. Weather exists because temperatures differ between regions. Stars shine because gravity compresses matter unevenly. Memory exists because biological systems maintain organized states against entropy through constant energy consumption. But the future universe gradually removes differences. Temperatures equalize, matter disperses, energy gradients weaken, and without gradients, meaningful processes become impossible. The terrifying possibility is not simply that life ends, it is that the universe may eventually lose the physical ability to support complexity at all. No engines, no metabolism, no stars, no computation, no thought, only equilibrium approaching across inconceivable durations. This future state is sometimes called heat death. The phrase sounds dramatic, but the underlying reality is colder than drama. Heat death does not mean fire or destruction. It means the exhaustion of usable energy, a universe where energy still exists, but no longer in forms capable of producing organized activity, a cosmic ocean with no currents, perfect stillness. And the more physicists explore the mathematics of this future, the more unsettling the implications become. Because once black holes vanish, the universe enters an era stranger than almost anything human beings naturally imagine possible. An age where reality itself becomes nearly featureless. Human beings measure existence through events. A heartbeat, a sunrise, a conversation, the collapse of an empire, even silence, from a human perspective, is understood as the temporary absence of activity before something eventually happens again. But the future universe described by thermodynamics introduces a condition far stranger than silence. A reality where meaningful events themselves become rare, then almost impossible, then perhaps physically impossible altogether. This is where the scientific picture stops feeling merely astronomical and begins affecting the emotional meaning of existence itself. Because the deeper implication of entropy is not simply decay. It is the gradual elimination of possibility. Right now, the observable universe remains filled with differences. Stars are hotter than surrounding space. Galaxies contain dense regions of matter separated by enormous voids. Living organisms maintain delicate chemical imbalances inside their cells. Planets orbit stars. Black holes distort space-time intensely compared to the emptiness around them. Reality still possesses contrast, and contrast allows change. Every meaningful process depends on imbalance somewhere. A river flows because elevation differs between locations. Weather exists because temperature varies across Earth's surface. Biological metabolism functions because organisms extract usable energy from their environments before releasing lower quality waste heat outward. Even human thought depends on imbalance. Neurons exchange electrical signals because ions are distributed unevenly across cellular membranes. The brain continuously consumes energy simply to maintain organized structure against thermodynamic drift. Consciousness itself may be understood, at least partially, as a temporary pattern sustained by energy flowing through matter. This means every memory, emotion, and identity exists inside a larger battle against entropy, a battle no system ultimately wins forever. The universe currently permits local victories. Stars temporarily resist gravitational collapse through fusion. Civilizations temporarily resist chaos through organization. Life temporarily resists chemical equilibrium through metabolism. But the cosmos extracts payment for every local increase in order by generating larger increases in entropy elsewhere. This principle governs everything, and once understood deeply, it changes the emotional texture of the future. Because the terrifying reality is not that the universe becomes violent, it becomes exhausted. Imagine a campfire late at night. At first the flames leap upward energetically. Sparks burst into darkness. Heat radiates strongly enough to illuminate faces gathered nearby. But eventually the fuel diminishes. The fire weakens. Colours fade from bright yellow into dim red embers. Motion slows, heat decreases, silence deepens around the remaining glow. The future universe resembles this process on incomprehensibly larger scales. Not a catastrophe, an exhaustion. And the exhaustion affects more than stars. Matter itself may not be permanent. Modern particle physics suggests that protons, one of the fundamental building blocks of ordinary matter, could potentially decay over enormous spans of time. No confirmed observation has yet detected proton decay directly, and the standard model of particle physics does not require it absolutely. But many grand unified theories predict that protons are ultimately unstable. If true, the implications are devastating for the long-term future of structure. Every atom inside planets, oceans, buildings, bones, and stars depends on stable protons. Matter appears durable because proton lifetimes, if finite, are extraordinarily long. Current experiments suggest a proton survives at least around 1034 years or more. Human intuition hears this number and interprets permanence. Physics does not. Compared to the deepest future, even this duration becomes temporary. If protons eventually decay, then ordinary matter itself slowly dissolves. Stellar remnants disintegrate particle by particle. Ancient black dwarfs evaporate into lighter particles and radiation. The cold remains of planets lose physical integrity across spans of time so enormous that galaxies already ceased existing unimaginably long before. The universe literally begins dismantling matter. This realization pushes cosmology into profoundly unfamiliar territory. Most people intuitively imagine the future as containing objects, perhaps dead objects, frozen objects, lonely objects, but still recognizable things occupying space. Proton decay threatens even this assumption. The cosmos may eventually become dominated not by stars or planets, but by thin radiation and isolated subatomic particles drifting through expanding emptiness. And expansion itself continues simultaneously. This matters enormously, because expansion does not merely separate galaxies, it dilutes interaction. Over time, particles become increasingly isolated from one another. Distances widen faster than structures can reconnect. The universe approaches a condition where encounters between particles become fantastically rare. Imagine an ocean expanding forever while the number of molecules inside it gradually decreases. Eventually, the meaningful collisions nearly vanish. The future universe trends toward this kind of isolation. Not absolute nothingness, but practical nothingness. A state where matter exists too sparsely and energy flows too weakly for complexity to emerge again. This creates one of the most psychologically unsettling implications in all of cosmology. The universe may possess a finite era of meaning, not meaning in the human philosophical sense, but in the physical sense, an interval during which structured processes can actually occur. Stars shining, planets orbiting, chemistry unfolding, life evolving, thought happening. Outside this interval, reality may become too chaotic early on and too exhausted later to support anything resembling organized existence. Human civilization emerged during the middle of this narrow thermodynamic window. That fact becomes increasingly eerie the more one contemplates it, because it means consciousness may not be a permanent feature of the cosmos. It may be a brief side effect produced while energy gradients remain available, a temporary phenomenon occurring between two immensities of lifelessness. And yet humans instinctively imagine intelligence as central. We tell stories placing consciousness near the climax of cosmic history. Civilizations often assume that awareness represents progress, destiny, or culmination. But the universe itself shows no obvious sign of privileging intelligence. Physics continues indifferently. Entropy rises whether observers exist or not. Stars die regardless of whether anyone watches. The cosmos may spend nearly all of its existence empty of thought. This realization destabilizes something ancient inside human psychology. The assumption that existence was somehow moving toward us. Instead, The scientific picture increasingly suggests that conscious life emerged accidentally inside temporary conditions unlikely to persist. Even memory becomes cosmologically fragile. Every human archive will eventually disappear, stone erodes, metals decay, orbits destabilize, stars engulf planets, black holes evaporate. If proton decay occurs, even the atoms encoding information eventually vanish. Nothing material appears capable of preserving civilization indefinitely. The future does not merely erase humanity, it erases the evidence humanity ever existed. And not only humanity, every species, every city, every work of art, every language, every religion, every digital record. All of it occupies a vanishingly thin layer of cosmic time, a brief thermodynamic pattern unfolding near the beginning of a universe that may continue incomprehensibly longer after all memory disappears. This is where the emotional scale of cosmology changes again. The future no longer feels merely large. It begins feeling indifferent. Not hostile, not malicious. Indifference is colder than hostility. An enemy at least recognizes your existence. The universe described by physics does not appear to care whether complex structures survive at all. The same laws producing galaxies also dismantle them. The same thermodynamics permitting life eventually extinguish the conditioned life requires. And beneath this indifference lies another terrifying implication still waiting in the dark. Because even heat death may not represent the final layer of reality's instability, the vacuum of space itself may not be safe forever. Space appears empty because human senses evolved at the wrong scale. When people imagine vacuum, they picture absence. A hollow region where nothing exists except darkness between distant objects. But modern physics increasingly suggests that what humans call empty space may actually possess hidden structure more fundamental than matter itself. And if that structure is unstable, then the future of the universe becomes even stranger than heat death. To understand why, it becomes necessary to step beyond stars, galaxies, and black holes into the underlying fabric from which physical reality emerges. Everything familiar, atoms, planets, oceans, nervous systems, civilizations depends on the behavior of quantum fields permeating space. According to modern particle physics, particles are not isolated little objects floating through emptiness. They are excitations of deeper fields existing everywhere simultaneously. The electron field, the quark fields, the electromagnetic field, the Higgs field. Reality resembles an immense ocean of invisible structures whose vibrations produce the physical universe humans experience. And like all physical systems, these fields may possess different energy states. This is where the possibility becomes unsettling. The universe might not currently occupy its lowest possible state. Imagine a boulder resting inside a shallow valley on the mountainside. From nearby, it appears stable. It can remain motionless for enormous periods of time. But somewhere lower exists a deeper valley, representing a more stable condition. If disturbed strongly enough, the boulder could suddenly roll downward into this lower state, releasing enormous energy and permanently changing the landscape around it. Some physicists believe the vacuum of space itself may resemble this situation. What humans perceive as stable reality could actually represent a metastable state temporarily stable, but not ultimately the lowest energy configuration possible. If true, the implications are difficult to emotionally absorb, because it means the laws of physics themselves may not be permanent. This idea emerges partly from measurements involving the Higgs boson discovered at CERN in 2012. The measured mass of the Higgs particle, combined with properties of other fundamental particles such as the top quark, places the universe surprisingly close to a boundary between long-term stability and metastability. The calculations remain uncertain. Small measurement changes could alter the conclusion. Many physicists suspect unknown new physics may ultimately stabilize the vacuum completely, but the possibility remains scientifically serious enough to contemplate, and contemplation leads into one of the most terrifying scenarios modern cosmology has produced: vacuum decay. The phrase sounds technical. The reality would be absolute. If the vacuum is metastable, then somewhere within space-time a quantum fluctuation could eventually trigger transition into a lower energy vacuum state. Once formed, this new vacuum would expand outward at nearly the speed of light. Inside it, the laws of physics would differ fundamentally. Atoms might become impossible. Chemistry might fail completely. Matter as humans understand it could instantly disintegrate, not through explosion in the ordinary sense, through replacement. Reality itself rewritten. The most disturbing part is how invisible the process would be, because the bubble expands at essentially light speed. No warning could ever arrive beforehand. The destruction of Earth, the solar system, and the galaxy would occur before any information about the approaching boundary could reach observers. One moment existence continues normally. The next moment the structure permitting existence is gone. And yet even this possibility unfolds against timescales so enormous that the mind struggles to place it emotionally. Vacuum decay may never happen at all. If it does occur, the universe could remain metastable for spans vastly exceeding even black hole evaporation timescales. Still, the existence of the possibility changes something profound in humanity's understanding of permanence. Not only may stars and matter be temporary, the underlying rules generating matter may also be temporary. Reality itself begins feeling conditional. This is where existential scale deepens into something colder than ordinary fear, because human beings instinctively assume physical law is fixed. Gravity tomorrow behaves like gravity today. Electrons continue carrying the same charge. Space retains the same dimensional structure. Civilization rests psychologically upon this reliability, even when people rarely think about it consciously. But cosmology increasingly reveals a universe where permanence retreats at every level examined. Planets are temporary, stars are temporary, galaxies are temporary, black holes are temporary, potentially even vacuum structure is temporary. The deeper science descends, the less solid reality appears. And this instability unfolds inside a cosmos already becoming incomprehensibly vast. By the era of black hole evaporation, expansion will have transformed the observable universe beyond recognition. Nearly every galaxy beyond local gravitational remnants will already have disappeared over the cosmological horizon. Distances between surviving structures become so enormous that light itself effectively loses practical usefulness as a means of connection. Civilizations, if any survive, become cosmically isolated beyond anything humans naturally imagine. Imagine attempting communication across distances requiring longer than entire stellar eras for messages to arrive. Now imagine those distances continuously increasing faster than signals can cross them. Eventually isolation becomes absolute. The universe fractures observationally into disconnected islands surrounded by unreachable darkness. And even these islands decay internally over time. This progression introduces a haunting reversal in the meaning of scale itself. Human beings often imagine larger scales as implying abundance. More galaxies, more stars, more worlds, more possibilities for life. Science fiction frequently portrays advanced futures spreading outward endlessly across populated cosmic landscapes. But real cosmological scale produces the opposite emotional effect. The larger the universe becomes, the emptier it feels. Because immense volume combined with accelerating expansion creates separation faster than complexity can sustain connection. A trillion galaxies sound crowded until one understands the distances between them. Immense time sounds generous until one realizes almost all of it may occur after complexity dies. The future universe becomes not richer, but lonelier. This loneliness deepens further once heat death approaches fully. Eventually, after black holes evaporate and matter thins toward diffuse radiation, meaningful physical events become extraordinarily rare. Quantum fluctuations may still occur. Tiny particles may occasionally interact. But organized structures capable of memory or observation become effectively impossible. The cosmos drifts toward near equilibrium. An equilibrium is psychologically horrifying because it eliminates narrative. Human beings require change to perceive meaning, Stories depend on transformation. Life depends on asymmetry. Thought depends on sequential differences between mental states. A universe approaching perfect equilibrium slowly removes these distinctions. The future after heat death may contain almost no events at all. Not because time stops, but because nothing meaningful remains capable of happening. Imagine a clock continuing forever inside a featureless room where absolutely nothing changes. Eventually, duration itself loses emotional meaning. Without events, time becomes difficult even to conceptualize. This may represent the ultimate direction of cosmological evolution, not destruction, but stillness. An endless thinning of structure until reality approaches featureless persistence. And somewhere inside this immense future lies perhaps the most uncomfortable realization of all. Human civilization emerged astonishingly early. The current universe, bright with stars, crowded with galaxies, warm enough for oceans and biology, may represent only a fleeting luminous preface before incomprehensibly larger eras of darkness and silence dominate everything afterward. The age humanity calls normal could actually be the rare exception, a temporary burst of complexity suspended inside an overwhelmingly cold cosmos. There is a peculiar arrogance hidden inside ordinary human perception, not arrogance in the moral sense, something quieter, a biological assumption so deeply embedded in consciousness that most people never notice it at all. The assumption that the world humans experience is approximately normal. Trees feel normal, oceans feel normal, warm sunlight, blue skies, gravity beneath the feet. Other living minds nearby these conditions become psychologically invisible because every human nervous system evolved entirely within them. The brain treats familiar circumstances as baseline reality rather than rare environmental luck. But cosmology steadily dismantles this assumption. The deeper the universe becomes understood, the more unusual human existence appears. Earth itself occupies an extraordinarily temporary balance point. The planet formed within a narrow circumstellar region where liquid water could persist. Its atmosphere remained stable long enough for chemistry to evolve into biology. Mass extinctions repeatedly reshaped life without fully sterilizing the surface. A magnetic field shielded organisms from lethal radiation. Plate tectonics recycled carbon slowly enough to stabilize climate across geological eras. Even these conditions alone are precarious. Yet against the backdrop of cosmic time, they become almost impossibly fragile. Human civilization emerged during an even narrower interval. Not too early, when the universe lacked heavy elements forged inside ancient stars. Not too late, after stellar formation had begun declining toward darkness. Humanity arrived while galaxies still filled the sky, while stars remained abundant, while planetary chemistry could still support oceans and atmosphere. The timing is unsettling. If intelligent life had emerged trillions of years later, the observable universe would already look profoundly different. Future astronomers may inherit skies almost entirely empty beyond their local galactic remnants. Evidence for cosmic origins would largely vanish beyond expansion horizons. The Big Bang itself could become unknowable. Human beings appeared during one of the few eras when the universe could still be understood, and even now, understanding arrives only partially. This realization destabilizes humanity's emotional position inside reality. Civilization begins feeling less like the center of cosmic history, and more like a temporary observer fortunate enough to exist during a brief interval of visibility before darkness deepens. The numbers involved intensify this discomfort. The observable universe contains perhaps more stars than grains of sand on every beach across Earth combined. Yet the human species occupies only a single small planet around one ordinary star near the outer edge of a fairly typical galaxy. Even the Milky Way itself spans roughly 100,000 light-years across. Light moving at the fastest speed permitted by physics still requires 100,000 years to cross it. Modern civilization has existed for only a tiny fraction of that duration. If all recorded human history were compressed into a single human lifetime, Light would not even have crossed our galaxy once during the entire period, and the Milky Way is only one galaxy among trillions. Human intuition cannot naturally process this scale because evolution never required it. Early humans survived by tracking predators, remembering landscapes, recognizing social patterns, and predicting seasonal changes. Nothing in biological history prepared the brain to emotionally comprehend a universe spanning billions of light years and trillions upon trillions of years into the future. As a result, the mind automatically shrinks reality into psychologically manageable proportions. People speak casually about space as though it were a destination rather than an abyss. Galaxies and documentaries appear close together because images compress enormous emptiness into flat visual frames. Science fiction often portrays interstellar civilizations moving comfortably between stars as if the universe were fundamentally designed for travel and expansion. Real cosmology paints a colder picture. The universe is not built for biological creatures. It only temporarily permits them. Even communication across interstellar distances becomes haunting when emotionally translated into lived experience. A message sent to the nearest star system travelling at light speed would still require years to arrive. Responses would take years more. Entire human relationships would unfold during the exchange of a few sentences. Across galaxies, the situation becomes almost absurd. Light from the Andromeda Galaxy reaching Earth tonight began its journey long before human civilization existed. The photons entering telescopes now departed Andromeda, when ancient humans still hunted with stone tools. Cosmic observation is always observation of the past. Astronomy is archaeology conducted across time itself. This means the universe humans emotionally experience is already partly gone. Some stars visible tonight may already have died. Some galaxies observed through powerful telescopes no longer exist in the form their ancient light still displays. The farther outward astronomers look, the farther backward in time reality appears. The cosmos visible to humanity is not the cosmos as it currently is. It is a layered archive of vanished moments, and eventually, even those archives disappear. Expansion ensures that more and more galaxies become permanently unreachable over time. Their light stretches beyond detectability. Their histories vanish from observable reality. The universe slowly erases its own memory. This has profound implications for meaning. Human beings instinctively associate significance with persistence. We preserve monuments, write histories, construct archives, and teach descendants because memory creates continuity across generations. Entire civilizations dedicate enormous effort toward resisting oblivion, but cosmic timescales overwhelm all such attempts. Every human achievement exists inside a universe fundamentally hostile to permanence. Languages disappear. Species vanish. Continents reshape. Stars die. Galaxies drift beyond observation. Even atoms may decay. The terrifying implication is not merely mortality. It is erasure. The future universe does not appear to preserve narratives. It dissolves them. Imagine all of human civilization compressed into a single flicker of light, visible briefly inside an immense dark ocean. From the perspective of cosmic time, that image may actually overstate humanity's duration. And yet, strangely, this fragility also transforms the emotional meaning of consciousness itself. Because against such overwhelming scale, awareness becomes extraordinarily rare. The universe existed for billions of years before the first living organisms emerged on Earth. For most of cosmic history, as far as science currently knows, there may have been no observers anywhere at all. Vast galaxies spun silently through darkness without witness. Supernovae erupted unseen. Black holes consumed matter in total solitude. Consciousness appears late, fragile, localized, possibly temporary on cosmic scales. This realization produces a subtle psychological inversion. Human beings often fear insignificance because the universe feels too large. But perhaps largeness also makes consciousness more extraordinary precisely because it is so difficult for reality to produce. The atoms composing the human brain were forged inside ancient stellar explosions. Over billions of years, those atoms assembled into organisms capable of looking outward and understanding the universe threatening to erase them. Matter briefly became aware of cosmic mortality. Then eventually, according to every known physical law, that awareness disappears again. This may be the most haunting aspect of all. The universe does not merely contain death. It contains the temporary emergence of beings capable of understanding death before being reclaimed by the same thermodynamic processes they observed. Civilization becomes a brief flare of self-awareness inside an overwhelmingly indifferent cosmos. And beyond humanity's extinction, beyond the death of stars and galaxies, the universe continues expanding into even deeper isolation still, because the larger structure surrounding everything visible may itself be stranger than humans naturally imagine. The observable universe is not the universe. This distinction seems simple at first, almost semantic, but it quietly contains one of the largest psychological fractures in modern cosmology. Everything humanity has ever seen, every galaxy captured by telescopes, every quasar, every nebula, every star whose light has reached Earth since the beginning of time, exists inside a limited sphere, determined by the speed of light and the age of cosmic expansion. Beyond that horizon, reality continues. How far, no one knows. Possibly forever. Human beings instinctively imagine horizons as edges. Ancient civilizations saw oceans stretching outward until they vanished beneath the sky, and naturally assumed the visible boundary represented a termination point. Even now, people often unconsciously picture the observable universe as a kind of cosmic container holding everything that exists. But the observable universe is only the portion light has had time to reveal. The larger structure beyond it may be vastly greater, potentially infinite, and this possibility changes the emotional scale of existence again. The observable universe already contains distances so enormous they resist comprehension. Light crossing from one side to the other requires roughly 93 billion years due to cosmic expansion. Within this volume exist trillions of galaxies and more stars than human language can meaningfully visualize. Yet according to the simplest interpretations of modern cosmology, this immense structure may still represent only a tiny patch of something incomparably larger, a single visible clearing inside endless darkness. This realization emerged gradually through studies of cosmic geometry and inflation theory. Observations suggest the universe on large scales appears remarkably flat, rather than curved sharply inward or outward. A flat geometry implies one unsettling possibility. Space may extend indefinitely beyond what humans can ever observe. No edge, no center, no final boundary. Just continuing structure beyond every reachable horizon. If true, the emotional implications are profound. Human beings naturally seek containment. Rooms have walls, planets have surfaces, oceans have shores, even stories possess endings. The mind feels uneasy confronting systems without boundaries because boundaries provide orientation. An infinite universe removes orientation entirely. Every galaxy becomes local. Every civilization becomes isolated. No location occupies a privileged position because no central position exists. Reality loses narrative symmetry, and inflation theory deepens this strangeness further. According to current models, the early universe underwent an extraordinarily rapid expansion shortly after the Big Bang. Tiny quantum fluctuations stretched across enormous scales, eventually becoming the seeds of galaxies and cosmic structure. But some versions of inflation suggest expansion may not have stopped everywhere simultaneously. Instead, inflation could continue eternally in distant regions beyond observable reach. This idea leads towards one of the strangest concepts in theoretical physics: eternal inflation. In such models, observable universes like ours become temporary bubbles forming within a vastly larger inflating background. New regions continually emerge while expansion elsewhere continues indefinitely. reality transforms from a single universe into something more like an endless cosmological landscape, a multiverse. The word is often treated casually in popular culture, but emotionally its implications are difficult to absorb. Human beings already struggle to emotionally process one observable universe containing trillions of galaxies. A multiverse potentially replaces this with endlessly repeating cosmic domains separated by unreachable expansion, not simply large, unbounded, and if physical laws vary between regions, then even the constants humans regard as fundamental may represent only local conditions rather than universal truths. Gravity here, different physics elsewhere, different histories, perhaps entirely different forms of matter or space-time, or perhaps nothing capable of structure at all. Science remains uncertain here. Inflationary multiverse models are mathematically serious, but experimentally difficult to confirm directly. Some physicists accept them cautiously, others remain skeptical. Yet regardless of which interpretation ultimately proves correct, one emotional consequence already remains unavoidable. Humanity's universe no longer appears singular or central. Cosmology repeatedly pushes civilization outward from every imagined position of importance. Earth was not the center of the solar system. The Sun was not the center of the galaxy. The Milky Way was not the center of the universe. Now, even the observable universe itself may not represent the whole of reality. Each scientific expansion reduces the psychological size of the human world, and the reduction continues, because the observable universe is also changing over time. Expansion creates horizons not only in space, but in causality itself. There are galaxies currently visible whose future light will never reach Earth, no matter how long humanity waits. Space expands too rapidly between distant regions for signals to bridge the growing separation. This means parts of the universe are already becoming permanently inaccessible, not technologically difficult to reach, physically unreachable. The cosmos slowly partitions itself into disconnected regions, and over immense timescales this process accelerates. Future civilizations, even if unimaginably advanced, and may inherit only tiny isolated remnants of what once existed observationally. The larger structure recedes forever beyond cosmic horizons. Information disappears into unreachable distance. This produces an eerie parallel with human mortality. Individuals lose memories through aging. Civilizations lose knowledge through collapse. The universe itself appears to lose observable structure through expansion. Reality forgets, and this forgetting unfolds on scales so immense that human language begins failing to capture the emotional texture of the process. Words like empty or lonely still carry biological associations with rooms, landscapes, or temporary isolation. Cosmic isolation is colder. Imagine a future civilization surviving around the remnants of a dead galaxy trillions of years from now. No other galaxies visible. No evidence of cosmic origins detectable. Darkness in every direction beyond local stars already extinguished. Expansion having erased nearly all traces of the wider universe. Now extend this isolation farther. Imagine the last surviving structures after black hole evaporation. Sparse particles separated by distances so large that interactions become fantastically improbable. No observers, no civilizations, no memory of stellar eras, only thin radiation drifting through expanding emptiness. Then extend farther still, potentially infinite space continuing beyond every horizon, mostly empty, mostly silent, perhaps forever. This is where scale stops producing wonder and begins producing vertigo, because human consciousness evolved inside finite environments. Forests, valleys, coastlines, social groups, all bounded systems where scale remained biologically navigable. Infinite or near-infinite cosmological structures overwhelm the architecture of ordinary intuition. The mind searches for center and finds none, searches for edge and finds none. searches for permanence and finds none. And beneath this vastness, thermodynamic decline continues uninterrupted. Even if the universe extends infinitely, local complexity still dies. Infinite emptiness does not comfort mortality. In some ways, it deepens it. The larger reality becomes, the thinner civilization appears within it. Human history transforms into a microscopic thermodynamic event, occurring briefly inside one small region of one galaxy among trillions. Itself, potentially only one temporary structure inside a vastly larger cosmic system, a flicker inside a flicker, and eventually, even that flicker disappears. The future universe grows not only darker, but more silent, because after enough time passes, there may be nothing left capable of witnessing the silence at all. Silence on Earth is never truly silent. A desert at midnight still contains moving air. Deep oceans still shift beneath invisible currents. Even empty rooms carry vibrations from distant cities. Electrical systems, insects hidden inside walls, the low mechanical breathing of civilization continuing somewhere beyond perception. Human beings have never experienced absolute silence because life itself is noisy. The universe, however, is moving towards something far closer. Not merely quiet, an absence of meaningful activity so complete that silence becomes one of the defining physical characteristics of reality. This future emerges gradually. At first, galaxies still exist. Stars continue shining weakly. Black holes drift through darkness, swallowing occasional remnants. Radiation crosses space. Rare collisions still occur, but as trillions upon trillions of years pass, events become increasingly separated by impossible intervals. The cosmos stretches, cools, thins, interactions fade. Imagine standing alone in an enormous cathedral after everyone has left. At first, you still sense recent presence. Heat lingers in the air. Footsteps echo faintly, but hour after hour, the structure cools, sounds disappear, dust settles. Eventually, the building feels abandoned in a deeper way, not temporarily empty, but forgotten. The future universe resembles this emotional transition on scales beyond comprehension. Reality itself becomes abandoned. This is one of the strangest implications of heat death. Popular imagination often portrays the end of the universe as explosive or catastrophic, but the scientific picture is colder and more psychologically difficult to visualize precisely because almost nothing dramatic happens. The future fades, slowly enough that no observer could emotionally perceive the full transition directly. Stars die one by one. Galaxies disperse gradually. Black holes evaporate across spans so enormous they defy intuitive comparison. The universe does not collapse into chaos. It relaxes into emptiness, and eventually emptiness dominates everything. By the time the final black holes disappear, the cosmos enters a state radically unlike the universe humans evolved within. No stable astronomical structures remain. No planets orbit stars. No galaxies illuminate the dark. Matter itself may already have decayed into sparse particles and low-energy radiation. The distances separating surviving particles become almost impossible to imagine emotionally. Atoms on Earth feel close because human senses evolved amid dense environments. Air itself contains roughly 1019 molecules per cubic centimetre. Even interstellar space, though extraordinarily sparse by terrestrial standards, still contains enough particles for gas clouds and stars to form. The deep future universe becomes incomparably emptier. A single particle may drift for durations exceeding entire stellar eras without encountering another. The cosmos transforms into a near-perfect vacuum extending across unimaginable distances, and yet time continues. This is perhaps the most emotionally disturbing feature of all. Human beings instinctively associate emptiness with endings. A burned-out building collapses eventually. A dead organism decomposes. An extinguished fire cools into darkness and disappears into surrounding nature. Biological intuition expects finality, but the future universe may continue indefinitely after meaningful structure ends. Reality persists beyond usefulness, beyond observation, beyond memory, an endless continuation of physical existence after almost everything recognizable has vanished. Imagine a clock still ticking inside a universe where no one remains to hear it. Then imagine the clock continuing not for years or centuries, but for spans so enormous that all previous cosmic history becomes negligible by comparison. The future after complexity dies may dominate the total lifespan of the universe. This realization quietly inverts humanity's emotional relationship with time. People often imagine themselves living late in history because civilization feels technologically advanced, yet cosmologically, humanity appears astonishingly early. The universe today remains crowded with stars, galaxies, radiation, chemistry, and active structure. Most of reality's future may still lie ahead, and most of that future may be dark. The age of life could represent only a thin, luminous layer near the beginning of cosmic history. Everything humans emotionally associate with existence: warmth, motion, biology. Civilization may be exceptional conditions rather than normal ones. The normal universe may actually be cold and empty. This idea becomes more unsettling the longer one contemplates it, because emptiness on cosmic scales is not passive, it actively isolates. Expansion ensures that surviving particles and radiation drift farther apart over time. Space itself continues stretching. Even if tiny fluctuations or rare interactions still occur, the increasing distances between regions reduce meaningful connection continuously. The future universe does not merely become empty, it becomes disconnected, and disconnection carries profound implications for information itself. Every thought, memory, and identity depends on relationships between physical states. Brains function because neurons influence one another. Civilizations exist because information flows between minds across time. Even stars depend on gravity, binding particles together into coherent structure. The future universe weakens all relationships. Matter separates, energy disperses, signals fade. Eventually, the cosmos may approach a condition where almost no organized information processing remains physically possible anywhere. A universe without observers, without records, without awareness. This introduces a haunting possibility. The overwhelming majority of cosmic history may occur unwitnessed. Human beings often unconsciously assume observation matters cosmically because consciousness dominates personal experience. But physics provides no evidence that the universe requires observers to continue existing. Galaxies formed long before biological life emerged on Earth. Stars exploded in silence for billions of years before any organism could understand what a star even was. And after consciousness disappears, the cosmos may continue silently for durations dwarfing the entire age of life itself. Reality does not appear dependent on meaning. Meaning appears dependent on temporary thermodynamic conditions. This realization creates a subtle existential loneliness difficult to fully articulate. Human civilization emerged capable of contemplating the universe precisely during the narrow era when contemplation remained physically possible. Consciousness became aware of cosmic mortality shortly before the cosmos itself began drifting toward irreversible exhaustion. Matter briefly opened its eyes, then eventually closes them again, and after enough time passes, there may be no trace anywhere that awareness ever existed at all. Not because civilization failed, not because intelligence lacks sophistication, but because the underlying physics governing the universe does not preserve complexity forever. Entropy eventually wins every local battle. The future cosmos therefore becomes not merely lifeless, but indifferent to the very possibility of life. An endless dark where even loneliness ceases because nothing remains capable of feeling lonely anymore. And yet this terrifying silence also forces another question. What did it mean that consciousness existed at all? Even briefly. Inside such a universe, perhaps the strangest fact about the universe is not that it will die. It is that, for a brief interval, parts of it became capable of understanding death. Across most of cosmic history, Matter behaved silently. Hydrogen drifted through expanding darkness after the Big Bang. Gravity slowly gathered gas into stars. Galaxies assembled, black holes formed. Supernovae scattered heavier elements across space. None of it required awareness. The universe functioned perfectly well without observers. Then, on at least one small planet orbiting one ordinary star, chemistry crossed a threshold. Matter organized itself into systems capable of preserving information, adapting to environments, and eventually reflecting upon existence itself. Life emerged, and much later consciousness began asking questions the universe itself may never answer. Why is there something rather than nothing? Why do physical laws exist in this particular form? Why does time move forward? Will existence continue forever? Human beings often imagine these questions philosophically, but cosmology transforms them into emotional confrontations with scale. The deeper science looks into the future, the more temporary consciousness appears against the backdrop of cosmic time, and yet temporary things can still possess extraordinary significance. A single human life lasts almost no time at all compared to stellar evolution. Entire civilizations rise and vanish faster than galaxies complete a single rotation. Even biological evolution occupies only a thin layer near the surface of Earth's history. But significance and duration are not identical. A lightning strike lasts only seconds. Still, it changes landscapes. Consciousness may occupy a similarly strange position within reality. Brief, fragile, yet uniquely capable of witnessing the universe that produced it. This idea does not erase the coldness of cosmology. The future remains overwhelmingly dark. Entropy still rises. Stars still die. The universe still appears indifferent to survival. But the existence of awareness introduces something thermodynamics alone cannot fully describe emotionally. Perspective. For billions of years, Earth rotated beneath empty skies before minds evolved capable of recognizing constellations. Oceans reflected moonlight long before any living creature understood what a moon actually was. The Milky Way stretched across prehistoric darkness unnoticed by countless extinct species incapable of conceptualizing galaxies. Then eventually neurons arranged themselves into structures able to comprehend cosmic scale. The atoms forged inside ancient stars became observers of stars. This is scientifically ordinary in one sense. Biology emerges naturally from chemistry under suitable conditions. Consciousness arises from physical processes inside nervous systems. No supernatural intervention is required, and yet emotionally the phenomenon remains astonishing, because the universe produced creatures capable of emotionally suffering from knowledge of the universe itself. Human beings are aware of mortality in ways few other organisms appear to be. Civilization developed rituals, religions, philosophies, and sciences partly as responses to the terrifying realization that existence is temporary. Modern cosmology magnifies this realization enormously. Not only individuals die, species die, planets die, stars die, galaxies dissolve, even black holes evaporate. The future strips permanence away layer by layer until only process remains. And still, despite this knowledge, consciousness continues looking outward. Perhaps that is one of the defining characteristics of intelligence, the refusal to stop asking questions even after discovering answers that provide little comfort. The night sky itself changes emotionally once viewed through this lens. Ancient humans saw stars as eternal guides, or divine lights fixed beyond earthly suffering. Modern astronomy revealed them as temporary thermonuclear structures destined for collapse. Yet, strangely, this scientific demystification often deepens emotional awe rather than reducing it, because the universe becomes more fragile, more contingent, more improbable. The light from distant galaxies no longer represents static perfection. It becomes evidence of fleeting moments crossing impossible darkness. Every visible star becomes a temporary victory against entropy. Every living organism becomes a brief arrangement of matter, resisting cosmic equilibrium for a little while longer. Even memory acquires new emotional texture. Human brains preserve fragments of reality temporarily before these patterns dissolve again. A childhood experience, a familiar voice, a civilization's literature, an entire species' history all exist as organized information vulnerable to time. Nothing known to physics protects memory indefinitely, and yet memory happened. This may sound insignificant against cosmic scales, but perhaps insignificance itself becomes difficult to define once consciousness enters the equation. The universe is overwhelmingly large, but largeness alone does not determine meaning. A galaxy cannot appreciate beauty. A black hole cannot mourn extinction. Empty space-time does not contemplate mortality. Consciousness does. The future universe described by physics may eventually contain no awareness whatsoever. Endless expanses of dark, cold reality, continuing mechanically without witness. If that future arrives, then every moment of observation happening now occupies an extraordinarily rare interval in cosmic history. Matter is temporarily awake. This realization creates a strange emotional duality. On one side lies profound insignificance. Human civilization occupies no central position. The universe does not appear designed for life. Most of cosmic history may occur without observers at all. Entropy eventually dismantles every structure humanity values. But on the other side lies something equally profound. Against overwhelming odds, the universe produced beings capable of understanding these truths. Creatures small enough to vanish cosmically in an instant, yet complex enough to calculate the lifespan of stars and predict the evaporation of black holes trillions of years into the future. The human brain evolved for survival on African grasslands, and yet it became capable of contemplating heat death. There is something haunting about this mismatch. Ancient instincts built for avoiding predators now confront infinite expansion. Proton decay and cosmological horizons, human emotions strain beneath scales they were never designed to endure. The mind searches instinctively for permanence and finds none. Still, it continues searching, perhaps because awareness itself resists final silence emotionally, even when physics predicts silence eventually arrives. And maybe that resistance matters in ways difficult to quantify scientifically. Not cosmically, not permanently, but locally, temporarily, like starlight itself. A candle does not become meaningless because it eventually burns out. Its light still existed against surrounding darkness. In much the same way, consciousness may represent a temporary illumination within a universe otherwise dominated by silence and empty space. Brief illumination, nothing more, yet perhaps nothing less. And still, beyond this reflection, physics continues toward its final implications. Because even after heat death, some theories suggest reality may remain unstable in ways stranger than ordinary extinction. The future may not simply become empty. It may become fundamentally unrecognizable. There is a point where cosmology stops feeling like astronomy. The stars are already gone. Galaxies disappeared unimaginably long ago. Black holes evaporated into thin radiation across expanses too large for intuition to survive intact. Matter itself may have decayed into sparse subatomic remnants, drifting through near-perfect darkness. And still, according to some theories, reality may not yet have reached its final state. This is where physics enters territory so alien that even language begins failing. Because human beings instinctively imagine emptiness as stable. Once structure disappears, the mind assumes nothing further remains capable of changing. A dead universe should simply persist, but quantum mechanics repeatedly undermines human assumptions about stability. The vacuum of space is not passive. Even in the deepest conceivable darkness, quantum fields continue fluctuating. Tiny temporary particles emerge and vanish continuously. Energy never becomes perfectly still. Absolute emptiness may not physically exist at all. This means the future universe could remain active in ways almost impossible to emotionally visualize. Not active with stars or life, active with instability. One possibility arises from quantum tunneling itself. In ordinary life, objects appear constrained by energetic barriers. A ball resting in a valley requires sufficient energy to climb over surrounding hills. Quantum systems, however, behave differently. Particles possess probabilities rather than fixed trajectories and under certain conditions. Systems can transition through barriers without classically crossing them. If the vacuum state of the universe is metastable, then somewhere within infinite or near infinite time, quantum tunneling may eventually trigger catastrophic transition into a lower energy state. Vacuum decay, again, the idea returns because its implications deepen dramatically once viewed against the larger scales of cosmic time. Most human fears involve destruction of existing structures. Civilizations collapse, planets explode, species disappear. But vacuum decay threatens something more profound than destruction: replacement. The laws of physics themselves rewritten. Imagine every constant governing chemistry and matter suddenly altered. Electrons no longer behaving identically. Nuclear forces changing strength. Atoms becoming unstable or impossible altogether. Inside the expanding bubble of lower energy vacuum, familiar reality may cease functioning completely. Not damaged, erased conceptually. The terrifying part is how casually physics permits this possibility mathematically. No cosmic law guarantees the permanence of the current vacuum state. The universe humans inhabit may simply occupy a temporary configuration lasting long enough for stars, planets, and biology to emerge before eventual transition occurs. Or perhaps the vacuum is fully stable. No one knows, and uncertainty itself becomes emotionally significant here, because it reveals how incomplete humanity's understanding remains even after centuries of scientific progress. Civilization learned to calculate stellar lifespans and black hole evaporation. Humanity mapped cosmic background radiation and measured expansion rates across billions of light years. Yet the ultimate stability of reality itself remains unresolved. This uncertainty matters because it exposes a deeper philosophical fracture beneath cosmology. Human beings instinctively search for foundations, some final layer beneath which nothing more uncertain exists. Ancient cultures sought permanence in gods, eternal heavens, or immutable cosmic order. Modern science replaced mythological certainty with mathematical structure and observational evidence. But physics increasingly reveals a universe where even the deepest structures appear conditional, temporary, contextual, potentially unstable. The farther downward science descends, the less solid reality becomes. Atoms once appeared indivisible, then came subatomic particles, then quantum fields, then fluctuating vacuum states. Every layer dissolves into deeper abstraction, and beneath all of it stretches cosmic time almost infinitely forward. This combination creates one of the most psychologically overwhelming possibilities in modern thought. Eternal decay, a universe continuing forever while gradually losing every recognizable feature. No final apocalypse, no definitive ending, only endless thermodynamic dilution across infinite time. The emotional horror of this idea emerges slowly because humans naturally associate infinity with abundance or transcendence. Religious traditions often portray eternity as fulfillment, completion, or everlasting meaning. Cosmological eternity may be the opposite. Imagine a universe where almost nothing happens anymore. Then imagine it continuing not for millions or billions of years, but forever. An endless continuation of near-empty existence after complexity has vanished permanently. This is where scale becomes almost unbearable psychologically. Human beings can emotionally process death partly because death implies conclusion. A life ends, a civilization collapses, a star burns out. Narratives possess boundaries. But infinite persistence without meaning violates narrative instinct entirely. The future after heat death may contain no climax, only continuation, an eternal dark where isolated particles drift through expanding space-time without destination, memory, or possibility of renewal. Some physicists attempt to escape this outcome through speculative cosmological models, cyclic universes, quantum rebirth scenarios, new Big Bangs emerging from previous cosmic states, baby universes forming inside black holes, exotic vacuum fluctuations spawning entirely new regions of space-time. These ideas remain deeply uncertain. Some are mathematically intriguing, some may prove impossible, yet emotionally their existence reveals something revealing about consciousness itself. The human mind resists terminal stillness. Again and again, civilization searches for pathways beyond endings, religious afterlives, scientific immortality, cosmic rebirth, even in theoretical physics. One senses the psychological pressure to avoid final equilibrium, but nature offers no guarantee of escape, and perhaps the most unsettling possibility is not destruction, it is irrelevance. Because regardless of which ultimate cosmological scenario proves correct, human civilization occupies only an infinitesimal fragment of the timeline involved. Every empire, language, ideology, and technological achievement unfolds near the very beginning of cosmic history. The age humanity calls ancient may be cosmologically microscopic. This realization changes the emotional meaning of the present moment. Right now, stars still shine across the sky. Galaxies remain visible. Oceans still move beneath lunar gravity. Life still exists on at least one world. Conscious beings still ask questions about the universe, threatening eventually to erase them. These conditions may not merely be temporary, they may be extraordinarily rare. A brief thermodynamic flowering inside overwhelmingly larger eras of silence, and eventually, if eternal decay truly awaits, even the memory of this flowering disappears completely. No monuments remain, no records survive, no observer recalls the age of stars. The universe continues, cold, thin, ancient beyond language. A reality so far removed from human experience that ordinary concepts like loneliness or darkness no longer fully apply, because loneliness requires someone to feel lonely, and in the deepest future there may be no one left anywhere capable of feeling anything at all. Eventually, the emotional violence of scale begins to quiet, not because the universe becomes less frightening, but because there are almost no remaining structures large enough to hold fear anymore. The stars are gone. The galaxies have dissolved into unreachable darkness unimaginably far apart. Black holes evaporated long ago into thin radiation spread across expanding space-time. Matter itself may already have decayed into sparse particles wandering through near-empty vacuum. The cosmos no longer resembles the universe human beings evolved within. No horizons, no worlds, no mornings, no visible motion except perhaps the slowest imaginable drift of isolated particles through endless dark. And still, time continues. This is the strange descent awaiting the far future, not catastrophe, but fading. Reality becoming quieter until silence itself loses contrast. Human minds instinctively seek images for endings. Oceans freezing beneath black skies. Dead planets drifting through abandoned galaxies. The final black hole evaporating in darkness. But even these images remain too dramatic. The true future may be far emptier than imagination comfortably permits, because once complexity disappears, there may be almost nothing left capable of producing recognizable events at all. The universe simply persists. Immense, cold, nearly featureless. And perhaps this is why the idea feels emotionally difficult to hold for very long. Human consciousness evolved around motion and change. The brain constantly tracks transitions, light becoming dark, danger becoming safety, hunger becoming satisfaction. Awareness itself depends on difference between states. A universe approaching equilibrium gradually removes those differences. The future after heat death may contain so little meaningful change that ordinary language begins failing to describe existence there. Terms like future and past lose emotional clarity once events become vanishingly rare. Duration itself becomes abstract without structure to measure against. What does a billion years mean inside a universe where almost nothing happens? What does eternity mean without memory? These questions reveal something unsettling about time itself. Human beings do not experience time directly. We experience change, heartbeats, sunsets, aging faces, moving shadows. Biological existence creates the sensation of flowing duration because organisms continuously transform. The deep future universe may possess almost none of this transformation, only persistence, a nearly static reality continuing across unimaginable expanses. And somewhere inside this silence lies one final inversion. Throughout history, humanity feared darkness because darkness concealed danger. Predators hunted at night. Storms emerged from unseen horizons. Ignorance itself became symbolized by shadow and obscurity. But cosmic darkness is different. It does not hide meaning. It reveals the absence of meaning humans expected to find. The deeper science looks into the future, the less evidence appears that the universe was moving toward any culmination at all. No final enlightenment, no permanent civilization, no cosmic memory preserving all things eternally. Only temporary structure emerging briefly before thermodynamics reclaims it, and yet the present moment still exists inside this process. That may be the strangest realization left after all the scale and silence are stripped bare. Right now, on one small planet orbiting one temporary star, conscious organisms still sit beneath the night sky asking questions about existence. The atoms inside human brains forged in ancient stellar explosions billions of years ago, briefly assembled into minds capable of imagining the death of the universe itself. Matter became aware of its own impermanence. Then eventually, according to every known physical law, that awareness fades again. Not dramatically, quietly, like starlight weakening across distance. There is something deeply haunting about the fact that the universe allows consciousness to emerge strongly enough to understand cosmic mortality, while offering no evidence that consciousness survives cosmological time. The awareness is temporary, but temporary things can still alter the emotional texture of reality. A song ends, a fire burns out, a civilization vanishes, yet during their existence, they change the shape of experience for those who encounter them. Perhaps consciousness occupies a similar role within the cosmos. Not eternal, not central, but real, brief islands of awareness suspended inside overwhelmingly larger darkness. And maybe that is enough. Not enough to defeat entropy, not enough to preserve civilization forever, but enough for the universe, however briefly, to contain observers capable of wonder, observers capable of fear, observers capable of understanding the immense silence waiting ahead. The future remains cold. Physics does not soften. Stars still die. Expansion still isolates. Entropy still rises. But somewhere within this terrifying scale exists a fragile beauty difficult to ignore. Against impossible emptiness, the universe produced beings capable of looking outward and recognizing emptiness at all. A brief moment where reality became self-aware before returning to silence. And eventually, far beyond every remaining trace of humanity, beyond every surviving atom of Earth, beyond even the final black holes dissolving into radiation, the cosmos settles into its long, dark persistence. No witness remains to describe it. No civilization remains to remember it. Only thin radiation crossing endless distances through a universe ancient beyond comprehension. The final quiet after everything luminous has gone away. In the end, the universe may not collapse. It may simply continue. Dark, silent, almost empty. The stars disappear first, though not all at once, for trillions of years. Isolated embers continue glowing weakly against expanding darkness before finally fading into cold remnants. Galaxies drift apart beyond visibility. Black holes inherit the cosmos briefly, then evaporate one particle at a time across intervals so enormous that the entire age of stars becomes only a forgotten preface to deeper time. After that, almost nothing remains. No worlds, no oceans, No biological eyes looking upward through atmosphere. No voices. No memory. Only thin radiation moving through distances too large for human intuition to survive intact. And still, space-time stretches onward. Perhaps forever. The terrifying part was never simply the death of stars. It was the realization that the universe does not require life to continue existing. Reality carries on long after warmth, consciousness, and structure disappear. The cosmos outlives every story told within it. Every civilization becomes temporary. Every monument vanishes. Every species occupies only a brief interval between two immensities of darkness. Yet for a little while the universe was awake. On one small planet around one ordinary star, matter arranged itself into minds capable of wondering how everything ends. Tiny conscious organisms emerged from ancient stellar debris and learned to measure galaxies, predict black hole evaporation, and stare billions of years into the future toward the exhaustion of all usable energy. The atoms themselves became curious, and perhaps that is enough to leave behind. Not permanence, not victory over entropy, only the fact that awareness existed at all, that somewhere within the enormous silence, the universe briefly contained beings capable of hearing the silence and feeling unsettled by it. Tonight the stars above Earth still burn, the Milky Way still stretches across dark skies beyond city lights. Galaxies still drift through the observable universe carrying the glow of ancient suns. The cosmos remains crowded with structure compared to the immense emptiness waiting ahead. Human beings live extraordinarily early, in the brief luminous era before the long dark, and maybe one day, long after humanity disappears, after Earth itself becomes dust orbiting a dead stellar remnant, the final photons from the last evaporating black holes will continue crossing endless space through a universe almost entirely devoid of events. No witness will remain to see them. No memory will survive to name them. Only darkness expanding quietly around fading light. The universe continuing beyond meaning, beyond history, beyond life itself.